Okay, welcome back. Going to Calculus 2. We are talking about problem number 1 on the second set of problems. Do that, probably just use A's and B's rather. So we have function x squared plus 4y cubed minus 6xy minus 1, and the instructions are find all the minimum and maximums and find all the saddle points. Okay, so this is a pretty standard, like here, this is a, you know, multivariate kind of a problem to deal with. Let's go ahead and give this thing a name. We'll call it F. We'll say that df by dx, we're going to go ahead and say that's 2x minus 6y. Um, Eventually, we're going to set that equal to 0. Over here, we're going to say df by dy, take the partial with respect to y. X goes to 0. We have 4x cubed, so that's going to be 12y squared minus 6x. We'll set this equal to 0. Okay, just to make sure that's what I did. It's exactly what I did. Okay, we've got some stuff to kind of reconcile here. So what I'm going to do is, let's see here. We have, yes, yes, we do. Okay, so we've got a 2x minus 6y set equal to 0. We've got a negative 6x. Okay, and then we have a plus 12y squared over here. Okay, and what I'm trying to do is we have to solve these two equations by either elimination, substitution, or something. I usually prefer to do elimination. So what I'm going to do here is I'm going to multiply this whole equation by 3 so that I can get this to be 6x minus 18y is set equal to 0. Underneath of it, we're going to have negative 6x, I didn't do anything to this, plus 12y squared is equal to 0. The reason why I make some room here is that when I want to add these together, I don't want to mess myself up and accidentally combine these two, because I will. So I'm just making room for the fact that I know that I will make this mistake if given the chance. So we're going to go ahead and try to prevent myself from making this mistake just by moving it over to keep all of my things all in a straight line. Add these two up, we end up with negative 18y plus 12y squared set equal to 0. We have to solve this. So we have 12y squared minus 18y set equal to 0. What we can do is, there's a y and a 6 out of both of this. So our greatest common factor, we'll say that's 6y. What do we have left? We have a 2y minus, it looks like 3 equals 0. So we'll go ahead and solve this. So we'll get y is equal to 0 as one solution, and y is equal to 3 halves for my other solution. Let's go back up and look at my x values, because, if we know what y is, we can go back and solve for x. So going back up to here, we say, okay, we've got 2x minus 6 times 0 equals 0. I think we're going to get x is equal to 0 for all of this, okay? And again, if I plug in y is equal to 0 in the other one, we're still going to get x is equal to 0 for the other one. Okay, what about the other time? Okay, what if happens if y is equal to 3 halves? Let's see what happens. So we have 2x minus 6 times 3 halves for my new y is equal to 0. Let's see what happens to x. So we have 2x minus, let's go ahead and do that. And it looks like we're going to get 9 here. So 6 divided by 2 is 3. 3 times 3 is that. So we end up with 2x equals 9. X is equal to 9 halves. Okay, what I like to do is, just in case, is what happens for the other one. Okay, so we had y is equal to 3 halves. Let's see if we can solve the other one for x. We have 12. You don't have to do this, but I like to do it just because what if I made a mistake on one of them? I want to double check to make sure that we're not going to be going anywhere. Let's see, I think we had x was equal to 3 halves. We have 12y squared, okay, minus 6 times 3 halves equals 0. So we'll go ahead and do that, and we'll say this is 12y squared minus 9 equals 0. Okay, I'm double checking to make sure that what I have over here is still working out over there. And Okay, oh, wait, sorry. If y is equal to 3/2, what am I doing? Get rid of this, x. If y is equal to 3/2, we're solving for x. Let me go back out of get rid of this. Okay, so we have, go back up here, we have 12y squared minus 6x. So 12y squared minus 6x equals 0. Okay, so y is equal to 3/2 here. Okay, yes. So we're going to have 12 3/2. So we're going to square this. This is going to be 9/4 minus 6x equals 0. 12 is 3 times 4 times 9/4. Some stuff is going to cancel, minus 6x. So we end up with 27 minus 6x equals 0. Go ahead and solve this. So we get 6x equals 27. X is equal to 27/6. And again, we could say that 27 is 9 times 3. 6 is equal to 2 times 3. Some stuff cancels. X is equal to 9/2. Hey, what did you know? X is equal to 9/2. So we have 2 points. We have the point 0, 0. We also have the point of 9/2, and then y was equal to, I believe, 3/2. Yes, 9/2, 3/2. Okay, so those are our 2 points that we have to actually deal with. Now, before we go off and dealing with points, we get to go ahead and deal with what is the second derivative of what's going on here. So we can go up to here. We can say, okay, I have my first derivative with respect to x. It's this guy up here. And we're going to take another derivative with respect to x. Thankfully, that answer is 2. Okay, now we're going to do the same thing. We have df dy squared. So we go up to where our y is. Okay, and dy. And we take their derivative again with respect to y. And it looks like we are just going to be getting 24y. Okay. Now, the last thing we have to do is we have to do d squared f dx dy. Again, remember that this should be the same regardless of which value, which order you take your derivatives in. But again, I like to double check it just to make sure. So we have df dx here. We're going to take our derivative with respect to y. We get -6. Okay. And just to double check it to make sure that everything is going in the right place, we have our derivative with respect to y here. Now we take the derivative with respect to x, and look at that, we also end up with -6. So that's always good to double check just to make sure that we are in the right spot. Okay, so again, the 2 points that we have to deal with are 0, 0, and then we also have 9/2, 3/2. Okay, those are the 2 points that we have to double check, or we have to make sure that we know what we're doing with it. Okay, we're going to go ahead and generate our d, which is fxx times fxy minus fxy squared. Okay, so fxx, that one was tough. Okay, fyy is going to be 24y minus, and I type in the -6 squared like this. So what I have here is 2 times 24. It should give me 48y minus 36. And then we have to try. Okay, what about our 0, 0 point? Okay, at 0, 0, my d, that goes to 0, is -36. D is less than 0. Okay, that's at 0, 0. Now we have to type in, what about for 3/2? Okay, so we only care about the 3/2 for here. Yeah, for the y, we don't really care about the 9/2, 3/2. We have 9/2 over here. So, okay, so 48 times 3/2 minus 36. What do we end up with? Let's see, that's going to be 3/2 over, it's going to be 24 times 3, which is 70 something. 70 something minus 36 is going to be b is greater than 0. This is for when, back up here, get rid of this. This is at the point we have 9/2, 3/2. We are going to consult the oracle, and we're going to say, okay, what happened with when D is going to be two different things. Okay, so in the first case, my D is less than 0. And we know that that's a saddle point. So we'll go ahead and label it. This is saddle point. So 0, 0 is my saddle point. Okay, when D is greater than 0, okay, we have either a relative min or a relative max, depending on what fxx is. So we can go up here and say, okay, well, fxx is always 2, so that's positive. So we go over here, we'll say, okay, fxx is 2, that's greater than 0. D was bigger than 0 because it was 70 something minus 30 something, so that's positive. So we have a relative min. Okay, so here we have a relative min. Okay, and I believe that's actually what we were asked to do, is find the saddle points and find the mins. So we have a saddle point at 0, 0. We have a relative min at 9/2, 3/2. That's what they asked us for. So I think we are done with the problem at that point. We could plug it in and see what the actual values are, but I don't think they really asked us to do that. And again, with the calculator, you guys will have a much easier time plugging these numbers in and getting values for it than I ever will. So I'm going to go ahead and stop our problem there and say, okay, that was the first problem of the second set. So good luck with the test, everybody. I hope this is helping you, and we will see you in the next video. All right, good luck.